So in number 4, the function is f of x equals x cubed minus 3x squared plus 20. And our closed interval is the interval x going between -1 and 3 inclusive. In interval notation, that's this interval, right? This is not interval notation right there. This is interval notation. It means the same thing. With the square brackets, it means include the endpoints in the domain. With the less than or equal to's, it also means include those endpoints. So the method is to find the critical points. Then you don't actually have to use the first or second derivative test. Just plug the critical points and the endpoints into the function. What gives you the biggest output? What gives you the smallest output? Those are the answers. This is actually a little easier than the first or second derivative test, a little less work. In theory, at least. So the derivative is 3x squared minus 6x. Want to set that equal to 0 to solve for any critical points. And by the way, if any critical points are outside the interval in question, then you ignore them. We can factor out a 3x here and be left with 3x times, in parentheses, x minus 2. And so this function has two critical points, 0 and 2. These are the critical points. Both of them are in the interval from -1 to 3. So we do need to use both of them. We do need to check the function values at these two critical points and at the endpoints. So you don't have to make a number line. You don't have to find the second derivative. Just find function values. Plug in -1, the left endpoint, plug in 0, the first critical point, plug in 2, the second critical point, and plug in 3, the right endpoint. Into the function, see what you get. Plug in -1, you'll get, I'm looking up here now, -1 cubed is -1. -1 squared is +1 times -3 is -3 plus 20 is 16. F of 0, you can see pretty quickly, is 20. F of 2 is 8 minus 12 plus 20 is 16. And F of 3 is 27 minus 27 plus 20. Okay, something a little strange here happened with this particular function and this particular interval. The global max and global min both occur at two values of x. The global min output is 16. It occurs at both the left endpoint, x equals -1, and the second critical point, x equals 2. I'll put the word value in here as well to emphasize I like to use the word value. And the global max value is 20. And that also happens to occur at two spots, x equals 0, the first critical point, and x equals 3, the right endpoint. Graphically, evidently, what's happening here on this interval is the graph is kind of symmetric looking. It must look like this, basically. Here's -1, here's 0, here is +2, and here is +3. This value is 16, and this value is 20. They're occurring. 16 occurs at two spots, and 20 occurs at two spots, like that. Okay, that just happened to be what the authors decided to do with this problem. Didn't have to be that way. If we use the same function in a different interval, we'd get different answers. Yeah, let me change the interval just to illustrate it. If we change the interval to be the interval from, say, -1/2 to 4, -0.5 to 4, we're going to get a different global max and min value. The graph, what will it look like? I'm predicting it'll look something like this. Over that interval, that'll be -0.5 there. This will be 0 still. This will be 2 still, but now at 4, it'll be pretty high. The global max value will occur at the right endpoint, and the global min value will occur at this critical point. The global min value will still be 16. I don't know yet what the global max value will be. I'll have to plug 4 into the function. It's 4 cubed minus 3 times 4 squared plus 20. That is 64 minus 48 plus 20. That's 16 plus 20 is 36 is the global max value on this interval occurring at that right endpoint. Question?
If the highest degree is positive in one of these functions, is it always going to be that the larger the rightmost endpoint is going to be the global max?
It depends on where the critical points are. Yeah, I mean, if we were thinking about this same function over some interval where the piece of the graph looked like this, then the global max is not at the right endpoint. Okay, it's same function, different interval, different answers, and different location of the global max. But you are thinking about the fact that this is cubic, and so as x goes to infinity, it goes to infinity. So if your interval is large enough, then the max will be at the right endpoint. But if it's not a large interval, not containing values of x far to the right, then it won't necessarily be at the right endpoint.